So, as I mentioned in the introductory video for the channel, I took a long break from RC car racing, and I'm just kind of getting back into RC car racing for right around a year. And one of the things that I wanted to look at here first was potential ways to use 3D printing to reduce the run cost. So again, for someone who's club racing, maybe I'm not trying to be the most competitive person. I'm not seeking every tenth of a second that I can get. Can I use 3D printing to, save me a little money on components that I know are going to be consumable? Now, something that I've seen in both my on and off-road cars are tires and wheels don't last as long as they used to. So I have some example wheels here. All of these wheels I have 3D printed. And what I want to see is how realistic is it to 3D print some wheels and put them on a car and then race them? Are the materials going to stand up to racing conditions? Are we going to be able to use this, or are we just going to be throwing money away because we put tires on wheels that just break? So for this video, I found a couple of different models on the internet that I was looking at. Like, this is an example of one of the models I found on Thingiverse, and this wheel is also a model I found on Thingiverse. And a couple things with these models: they didn't fit the car off of the print bed. I had to drill out the hole on both of them to get them to the right diameter for my spindle. And the way they were designed, the 12mm hex doesn't have any tolerance into it. So I wasn't the biggest fan of these models. What I'm going to use for the test is basically a wheel that I designed, and I'm going to have the link to that wheel in the video description. This is essentially the model. What I did with this wheel was I just put some extra tolerance in it to make sure that it fits the spindle and the drive hex right off of the print bed. First, what we're going to do is we're going to weigh all of these wheels we plan to test for our racing application. So the wheels are all the same model, printed with the same settings for infill, everything else basically the same for print settings. The only difference is the material the wheels are made out of. The first wheel is a PETG wheel, the second wheel is a PLA wheel, and then the third wheel is a wheel made out of nylon. Now for a control, I'm going to weigh an old wheel that I have. This is an associated wheel that you can see I've used and I've removed the tires from to get an idea of what a wheel you would buy weighs. So that wheel, 17.5 grams for the associated wheel. So first up is our PETG wheel. That wheel is 21.6 grams. Next up is our PLA wheel. This wheel, 21.5 grams. And last is our nylon wheel. And our nylon wheel is 18.3 grams. So the nylon wheel is pretty close to the stock associated wheel. The next thing that we want to see is how are these wheels going to stand up on impact. All the wheels I've printed so far that I've put on a car have basically broken on impact. So what I'm going to do is I'm going to take these wheels outside and I'm going to smack them with a hammer, see if they break. Okay, so we're outside and we're about to do our impact test with our 3 wheels. Before I do the impact test, I wanted to say that I have already tried one set of 3D printed wheels in just a track test. And I'm going to show those wheels and kind of why that wheel model and material are not part of this test. So the first set of wheels I printed were models I found on Thingiverse. It was 2 different models because my test car is an RC10 B64. So I needed a set of front wheel drive wheels and basically rear buggy wheels. I'll link the models that I used in the description, but the material I used was Bamboo Labs polycarbonate. And I was expecting the polycarbonate to work because polycarbonate is generally a strong material. I'll show the video of the track test so you can see kind of how I was driving the car. I wasn't really driving the car any different than I would when I was racing it. But basically, the polycarbonate, this is a front wheel, just couldn't stand up to the impact. I mean, this was about 5 laps on the track, just practicing. Rear wheel, I don't know if you can see, is cracked and broken on the sides. And then when I removed the tires from the wheels, you know, this wheel is the other rear wheel, was essentially destroyed on the inside. And this was all from just practice. I wasn't really doing anything, and realistically it was only about 5 laps of practice. So this polycarbonate just didn't work. So for our impact test, I'm going to do basically 3 impacts with the test wheels. So we'll just pick a test wheel. This is the PLA wheel. The first impact, I'm going to set the wheel in between these 2 pavers, and I'm just going to hit it with the hammer on the top. And the failure mechanism I'm trying to demonstrate here is basically what happened to this wheel. So coming off of a jump, am I going to break the wheel on the layer lines? If a candidate wheel survives that, I'm going to set the wheel flat, and I'm going to do basically an off-center strike, so on the edge of the wheel. And the failure mechanism there is basically what you see on this wheel. Do I break the edges of the wheel? Thinking like the track I race on is that the border is a pipe, so maybe I go too wide and I hit the pipe, or I take a jump wrong and I land on the pipe. Do I break the wheel? The next impact I'm going to do is on the center of the wheel, and that's essentially to simulate what happened to this wheel. This was the front wheel. In this model, like, I was kind of skeptical of this model because it's dished, and the dish is one extrusion with some, you can see some fins on the inside, supposedly to give it strength, but this wheel punched straight through the center, and this was it actually hitting the pipe, and it just punched straight through the center. So if the candidate wheel, this is going to be the last impact we do, is the center. So let's put our PLA wheel inside the pavers, and we'll do our first impact with the hammer. Now this is unscientific because I don't have a way to ensure that the impact force is the same. I'm just going to do the best I can. So our first impact, I think I actually hit the paver there, so I'm going to hit it again. You can see the impact dent. Doesn't look like the wheel is broken, so let's move on to our off-center impact. So here you see the PLA wheel basically failed, layer lines broken, so off-center, this wheel probably isn't going to work. I don't really see a point in doing the final center impact, so let's move on to our PETG wheel. So we'll do the center impact. PETG shattered. You know, again, this material probably isn't going to stand up to the impact of racing. PETG wheel broke. So here's our nylon wheel. This is our final test. Let's see what happens with the nylon wheel. I don't think I hit the wheel, so I'm going to hit it again. No real visible damage on the nylon wheel that I can see. So let's go on to our second impact test. Off center. Nylon wheel looks like it survived 2 strikes with the hammer off center. So let's do our center impact test. Nylon looks like it's a pretty good material. I just want to try this one more time. So I can break it on the layer lines, but I had to hit it a few times. I think I want to try the nylon, so I'm willing to commit a set of tires to this. So I'll print out a set of these nylon wheels, we'll glue them up, and we'll see what happens. So this is the test with the polycarbonate wheels. I just kind of wanted to show what kind of driving I was doing, what kind of stress the car was going under. It was just normal, and you see I'm the only one on the track right now, so there's nothing else, and there are no other cars out there for me to worry about. As I mentioned, these wheels didn't last more than 5 laps before they broke. So now I've got some wheels glued up, so we'll take it to the track and see if they survive. Alright, so this video here, this is basically the first track test with the nylon wheels. We had just gotten into the racetrack. This was like the first time around. Track was still kind of wet, so it was slick. Car was a little hard to drive. I was also having a lot of problems with the triple jump, so we're going to see that I had plenty of time to crash the car and see if the wheels were going to break or not. I didn't really notice any problems as far as handling of the car. Handled fine. I did crash a number of times, hard enough that I would have expected the wheels to break if they were going to. You'll see in one of the triple jump attempts, I flipped the car over, put it on its roof, and I think that's near the end of the video because I had to go get the car, so we had to stop shooting, but wheels didn't break, and I was able to finish this practice session. I did not race with them. That was because I did discover a couple of things with the models I want to change. But yeah, overall. So here we're continuing the session after I flipped the car over, and again, same kind of conditions. Track is still slick. I mean, it's nothing you can do about it at this point in the morning. We'll see in this part of the session that there is an area after I come off the double jump where I have an impact from another car where I would have expected the wheel to break. I mean, that crash you just saw off the triple, I would have expected the wheel to break if it was going to break. That was pretty tough, and I basically barrel rolled it. But I think it's coming up here where I come off of this double jump and this car behind me hits me. It was an impact right on the back wheel. I probably would have expected if a wheel was going to break, it was going to break there. And it didn't. I didn't see that problem. So wheels seem like they worked. It looks like you can 3D print nylon wheels. Take them to the track and race. Once I modify the models, I probably will post these if folks want to check them out. That would generally be supporting the efforts here, so potentially make some more videos. Okay, track test results. So first, let's keep in mind the overall purpose of the test is essentially, can we use 3D printed wheels to reduce the overall running costs for club racing? And that's really the focus, is club racing, not big races, not large state events, club racing. So overall, the nylon wheel did hold up during 2 practice sessions. We only saw a video for 1 practice session, but I took it out in 2 sessions and the wheels didn't break, they held up. Now at my skill level as a driver, I didn't really notice a difference in handling or performance of the car. Maybe someone who is a highly skilled driver or world champion class driver would notice, but I did not. I am planning to use a set of these the next time I need tires on the 4-wheel drive or on my 2-wheel drive buggy. I mean, my son's 2-wheel drive buggy is probably due for a set of tires, and I think I'm going to try these wheels. But why do we care about this? Like, why do this at all? Why not just buy wheels? So, again, in the context of club racing, which is what I plan to do, and I think a lot of people do, there's nothing really on the line. You're not winning anything and you're not losing anything. You're just racing for fun. If you win the A main, you don't really get anything, and if you lose, you don't really pay anything extra. So this is just for fun. Now, if we make some general assumptions on what a set of tires and wheels would cost for an off-road buggy, I'd say a full set tires and wheels is around $70. So if I do a bit of rounding, depending on the tires you buy, it's about $50 for all 4 tires. That's basically taking into account the purchase price of the tire and the taxes associated with it. Now, a full set of wheels, again, if we round a bit, is probably between $15 and $20 for all 4, depending on what you buy and taking sales tax into account. Now, these wheels that I made out of nylon, if we assume a material cost of $30 a spool, that worked out to $2.76 for all 4 wheels. So print all 4 of them out, $2.76. So if we average out that cost of wheels between $15 and $20 per set, and then we subtract the cost of the nylon, you do stand to save just under $15. I mean, it's slightly under $15 by using these nylon wheels. Now, while I was at the track, I spoke to a number of people, and I just wanted to see, do they try to reuse wheels at all, or do they just throw the wheels away after they were done, after the tires were worn? And most people said that they threw the wheels away. Now, if you think about it, there's 2 basic methods that you could reuse a set of wheels. So kind of like this. And those methods are chemical and heat. And the basic thing that people told me, or the consensus was, once you've used a set of wheels like this one, you see this wheel is beat up, so it's already been beat up, and then you subject it to heat, or you subject it to some kind of chemical like acetone or what have you to try to break up the glue and reuse the wheel, you've probably compromised the plastic, and it's just not worth it to use that wheel again, so they throw it away. And that makes sense, right? The plastic is probably degraded. Now, I did speak with one person who told me that they ran 3 buggies, and because of the classes they ran, they're running faster classes, they usually had to buy a set of tires a race day. Now, I don't know if they meant 1 set of tires per race day or 1 set of tires for 3 cars per race day. They didn't specify, but if we assumed they were buying 1 set of tires per car per race day, then they're spending $150 roundabout on just the tires, and wheels probably either between $45 and $60 depending on the wheel. So if they were able to print and use these wheels, if you average the wheel cost out, that person could save $50 per race day. And if you're just club racing, again, if they work and perform the same, that could be significant for you. So a few final thoughts on the materials. I decided to use these nylon wheels because of the impact test on the PLA wheel. But was that really a fair test? I mean, we saw the video and we saw what I did. Is that really fair? I do print a lot of PETG. PETG is the most common material I use in my printing. Basically, everything I've made out of PETG for an RC car has shattered. I found PETG is just brittle, and it doesn't stand up to impact once you have the car on the track. Now, the PLA wheel, if you remember from the video, the PLA wheel did survive the top-down strike. So when we had the wheel on its side, it did survive the top-down strike, and it broke on the off-center strike. But is that really a fair test, right? I mean, we are hitting it with a metal hammer, and it's on cement. So if you think about that top-down or the off-center test, the impact force doesn't have anywhere else to go other than the layer lines. So maybe that was an unfair test of the PLA. The PLA could deserve some further testing, but I don't really think that I trust the material enough to potentially waste a $50 set of tires on it. So if people are interested in that, go ahead and leave a comment if you'd like to see the PLA test, and I'll see if I can find a set of tires that I can put on them, like 2.2 tires for a buggy that'll, maybe $20 for the whole set. I mean, we won't race those, we'll just take the car and practice with it, but it should be a fair enough assessment because you're still on a racetrack and you're still driving it like a race car. So that could be something for the future. Now, my wheel model I am planning, once I have it all finalized, to post it on Cults 3D, and that'll likely be a paid model. So once that's done, you'll see the link in the video description. I'm going to have it as a paid model because, as I mentioned, I'm not sponsored in any way. All of this stuff I'm buying with my own money, so anything I made, if people wanted to buy the wheel model, any money I made would just go to, say, buying the tires for the PLA wheel test. Another test I might like to do is making a set out of high impact resin. I do have a resin printer, and though the resin printing could be a little slower, the post-processing could be easier because the support material is easier to remove. So if anyone happened to purchase the wheel, that could go into buying the high impact resin for that test. I guess finally, if there's another thought about something you may like to see, another wheel model or another test, just post that in the comments.